Welcome all of you. Welcome to another video in surface area volumes itself. Now since we are doing surface area volumes, I have just finished with cones and cylinders, and this is my video which is on surface area volume spheres. Okay, so I'll be taking up spheres, and this will also include hemispheres. So let's see what we have in this chapter. Okay, I repeat, you will find all the links of all chapters of surface area volume in the description box, so you can check there and check for cones, cylinders, or even combination sums of spheres and cylinders. Okay, so let us see what are spheres. We do have a lot of spheres around us, like we have the shape of a ball is a sphere. Okay, the earth itself is to some extent a sphere. So this circular shape, that is the three-dimensional shape of a circle, is called a sphere. Now here you have done it in your earlier classes. Now we'll have to find the volume here and the surface area of a sphere. Now there is nothing like a curved surface area or a total surface area of a sphere, because it is just one whole surface area. Okay, there is nothing like side and the top and the bottom for a sphere. So we have only one surface area, okay, which is the total surface area of a sphere. Otherwise we have the volume. Now volume of a sphere is 4 by 3 pi r cube. What is r? R is the radius of the sphere. Now remember, if we just get the radius of the sphere, we can get any sphere. Just like if we know the radius, we can get the circle. So radius of the sphere is r, therefore volume is 4/3 pi r cube. Okay, coming to the surface area, it is 4 pi r square. Okay, so now we know the surface area of a sphere. What would be the surface area of a hemisphere? Now this is a hemisphere. That is, you already know that we talk about a hemisphere all the time when we talk about the earth, the southern hemisphere, the northern hemisphere. So here this is nothing but half of the sphere. So when we have half of the sphere, then we have the volume of hemisphere is equal to, just divide this by 2. If we divide this by 2, we get a 2/3 pi r cube, right? Okay, so if we divide it by 2, we get a 2/3 pi r cube, and total surface area. Now here we have to pay attention. Total surface area of a hemisphere is 2 pi r square, that is half of this, plus another pi r square, that gives 3 pi r square. Okay, that gives me a 3 pi r square. Because why this pi r square? This is this surface, okay, this plane surface, which is a pi r square, and the circular portion is a 2 pi r square. Now coming to the curved surface area, if they ask only the curved portion, this portion, then it comes to only 2 pi r square. So curved, now if it comes to hemisphere, we do have a different curved surface area and a total surface area, but for a sphere we have only total surface area. Okay, so let's see, we'll do a few sums on this. Find the volume Find the volume and surface area of a sphere whose radius is 3.5 centimeters. Okay, so volume and surface area of a sphere whose radius is 3.5 centimeters. Then, so radius is 3.5. First, volume formula we know. Volume is equal to 4 by 3 pi r cube, which is 4 by 3 into 22 by 7 and r cube. 3.5 into 3.5 into 3.5. This is how you should write, 0.5. Okay, so now if I multiply this with this, point into 0.5 means into half, so 4 into 11 into 3.5 into 3.5 by the 3. So how do we further multiply it? So if we multiply this, we'll get a 44. Yes, we'll get a 44 with, and 3.5 with 3.5 gives how much? 12.25 into 44. Okay, so that comes to 539. Okay, 539 divided by 3. If we divide 539 by 3, we'll be getting okay 179.67 centimeter cube. That was the volume of the sphere. Okay, so we had to do some rough work here because the sum was like that, nothing was cancelling. Okay, coming to the surface area. Now come to the surface area. This surface area, when they say, it is the only surface area because it is a sphere. So surface area of the sphere is 4 pi r square, which is 4 into 22 by 7 into 3.5 into 3.5. Now here we can make it 0.5. That makes it 4 into 22, 4 into 11, sorry. Okay, if I multiply with 0.5, I get 11 into 3.5. That is 44 into 3.5. Okay, 44 into 3.5 is how much? Sorry, that is 154 centimeter square. Okay, so here also remember to put the repeated digit below while multiplying. When you put the repeated digit below while multiplying, you can actually, when you put it below, you can actually repeat this and your sum goes faster. Okay, so let's take up the next sum. The surface area of two spheres are in the ratio 1:4. Find the ratio of their volumes. So they have given us the surface area of the two spheres. So S1 by S2, 4 pi R1 square by 4 pi R2 square. Why? Because they both have a different radius. Okay, and that comes to 1 by 4. Here only I'll do the cancellation. Okay, so I get R1 by R2 square is 1 by 4. From this I can get R1 by R2 as a 1 by 2. Yes, so R1 by R2 is a 1 by 2. Now V1 by V2, V1 is to V2 is equal to how much? So V1 by V2, again I'll write the formula 4/3 pi R1 cube by 4/3 pi R2 cube. Okay, and now this cancels. Yes, so R1 by R2 cube, that is, I'll put 1 by 2 here. I'll just substitute from here. 1 by 2 cube, that is 1 by 8. Therefore V1 is to V2, V1 is to V2 is 1:8. So in these sums there is no requirement to take an x, Never take an x and write 1x, 4x and then add up and do all sorts of things. It is not required to take that x variable anywhere. You can just cancel these, and this writing pattern is very much important. If you write like this, you will get your sums correct more easy. So here is a question. A hollow spherical shell, okay, we have to understand this, is made out of metal of density. This is the density given here. Interior and exterior radiuses are given. Find the weight of the shell. Okay, now here the very first thing is we have to understand the volume of the material that has been used in making the shell. So shell is something like your Ferrero Rocher chocolate. Yeah. So here this is internal radius is an 8 and external is a 9. Okay, so we shall be finding the volume of material that has been used in making this sphere, okay, is equal to 4/3 pi r1 cube minus 4/3 pi r2 cube. Now what is r1 and what is r2? R1 is the external radius, R2 is the internal radius. Now what are we actually doing? We are getting this volume, external volume first, and from that we are kind of scooping out the internal one. Okay, so 4/3 pi R1 cube minus R2 cube, and that gives me 4/3, and this is 22 by 7, and R1 and R2 is, this is 9 cube, which is a 729 minus 512. 8 cube is a 512. So here how much do we get? 4 by 3 into 22 by 7. Okay, 4 by 3 into 22 by 7, and then on subtracting we get 217. Okay, now this goes by 7 clearly, 31, right? So it is, if we multiply the numerators, we get 2728 by 3. 2728 by 3. Now that is going to give us a decimal answer for sure. So how much we get here? We get a 909.3. Okay, so on dividing this we get 909.3 centimeter cubes. That is the volume. Okay, so that is the volume of material that is required in making this shell. But then density is given here as 4.5. Okay, if the density is given as 4.5, then we have to come back to this formula which says density is equal to mass per unit volume. This is the formula of density that we know. We know it from physics also. So now we are trying to find the mass. This is what they are asking. When they are asking for weight here, they are practically asking for the mass. So here density into volume is mass. So mass of the, what is the mass of the shell then? Mass is 909.3 into, that is 4.5. Now here we have to check one thing. Here it is in centimeter cube. Our answer is also in centimeter cube, so we can use it. So this is coming to, if we do this multiplication, we will be getting, now on multiplying this, we will be getting an answer of 4091.8 grams. Okay, but that doesn't solve our problem. If it is 4091.8 grams, we must convert it in kg and then give our answers. Okay, so we don't talk like this. If it is 4091.8, because it is more than 1000 grams, we should convert it to kg. So what we do, we divide it with 1000, and this is our answer, this many kg. Okay, this many kg is the 4.0918 kg is the weight of the hollow sphere when the density has been provided. So in this particular sum, what is important is first understanding how to find the volume of a hollow sphere. Second thing, what is important is this formula. If you don't know this formula, you will not be able to do this sum in the exam. Okay. Now this is our next question. This question is slightly difficult. So the internal and external diameters of a hemispherical vessel. Now hemispherical vessel is something like a bowl, okay, but then it has a thickness because the internal and external diameters are quite different, you can see, okay. So find the cost of painting the vessel all over at 14 paise per centimeter square. Now this is the hemispherical vessel. Here it has a thickness. Internal radius is a internal diameter is a 20, so internal radius is a 10 and external radius comes to a 14. So internal and external radius, that comes to 14. Then let us first find the surface area. How do we find the surface area of this? Okay, so first is external curved surface area, because we need to paint. If we need to paint, we have to find surface area. If we are melting, we need volume. So external curved surface area is how much? 2 pi r square, because 4 pi was for the full one, okay. So that will get as 2 into pi into r. R is how much? R is 14, yes, because external radius is 14 square. So we'll just leave it as pi into, this is 196 into 2. 196 into 2 is a 392. So 392 pi, we'll just leave it like this over here. That many centimeters squares. Okay. Now coming to the second part of it, we need to find the internal curved surface area. How do we find the internal curved surface area? So in order to do that, internal CSA, that is again one more 2 pi r square, but then it is the internal radius we are going to take. 2 into pi, this time the radius is a 10. So it is 10 square, which is pi and 200, right? Which is a 200 pi. Okay, so it's a 200 pi. And we are going to leave the sum over there. Now there is a ring. Remember the top part of the hemisphere, this part. Yeah, we are talking about this part now. We'll have to find the area of this also, because this is not negligible and it is quite a thick part. We need to paint that also. So how do we find the surface area of the ring? Okay, that is pi r square, that is I can say now capital R square minus pi small r square. What is that? Capital R is pi r square minus r square, okay, and that comes to how much? That comes to, this is pi, r is external is 14 square minus 100, 10 square, okay. 14 square minus 10 square, that comes to pi 196 minus 100, that comes to finally how much? 96 pi, isn't it? It comes to a 96 pi. So we'll leave the sum. Now these are our three answers, all three surface areas. Okay, what we are going to do is now we are going to add these three and that will give us the total area. Okay, so we are going to add them. So TSA now of the hemisphere is 392 pi plus 200 pi plus 96 pi. Take the pi out, 392 plus 200 plus 96, and that will give me, on adding, 688 pi. If it is a 688 pi, the cost of painting it, cost of painting is 688 pi into, I have 14 paise per, it is a 14 paise per centimeter square. So first let us convert paise to rupees. Okay, so this is going to take 688 into 22 by 7 into 14 into 100. See, this is the advantage of not cutting the 7 in every step. 7 2s are 14. So it is 688 into 44. 688 into 44 divided by 100, and we can straight away get our answer in rupees. So if we calculate this, this comes to 30272. 30272. When divided by the 100, it gives us point here. So rupees 302.72 paise. So 302 rupees 72 paise is our answer. That is the cost of painting this hemisphere all over when the cost of painting is 14 paise. So what is important here in this sum is not to use up the pi anywhere, not to get everything in terms of pi. See, your answer is going so